Hi everybody. In this lesson we want to look at some complex rational expressions. Now, a complex rational expression is something like this. It's basically a fraction of fractions. So it's not as if fractions by themselves aren't difficult enough. Here we have a fraction of fractions, but it's actually not that bad. And there's two methods commonly used to simplify complex rational expressions. And the most natural method is to just simply simplify the big numerator. So here's the big numerator, and simplify the big denominator by getting a common denominator so that these two fractions become one fraction. Then I'll have one fraction divided by another fraction, and then you can just invert and multiply. So if I were to look at the numerator, I see that this fraction has an x, but this one doesn't. So let's multiply this fraction by x over x. And this fraction has a y in the denominator, but this one doesn't. So let's multiply this and by y over y. And now I can combine those as 6y plus 7x all over xy. Okay? So I've got 6y plus 7x all over xy there, and then do the same thing in the denominator. So in this denominator I'll multiply here by y over y and here by x over x, and that's going to give me a common denominator again of xy. So I got 7y minus 6x all over xy. So now I have one fraction divided by another fraction, and I can just invert and multiply. So I've got 6y plus 7x over xy for this fraction, and if I invert and multiply this, I'll get xy all over 7y minus 6x. Okay, so these are all factors. Everything's multiplied, so I can go ahead and cancel. I've got an xy here that cancels, and I will just end up with 6y plus 7x all over 7y minus 6x. Okay? Now I think that's fairly natural and it's fairly easy, but there is another method that's not quite as natural, but it actually ends up being usually faster and easier. And it works in the circumstances like this one where the both of the big numerator and big denominator have a similar common denominator. Alright, so I'm going to look at that same problem now, and I notice that the common denominator of all these little fractions is x times y. So what I'm going to do is I'm going to multiply this whole numerator of this big fraction and the whole denominator of the big fraction by that least common denominator. I'm going to multiply by xy over xy. Okay? Now it's important to realize xy is just like xy over 1. Now you don't have to put the over 1 here, but I'm going to put it here just to emphasize that when I multiply this times this these two terms here, the xy multiplies the numerator, and then the 1 just multiplies the denominator. Okay? So when I do that, when I take and distribute this to this term and then to this term, notice that's going to give me, I'm going to get 6xy over the x. And you see this x is now going to cancel. And when I distribute over here, I'm going to get 7xy over the y. And so that y is going to cancel. And that's always going to happen if you multiply by the least common denominator. So you will be guaranteeing that this factor here is going to cancel with something in that least common denominator. So when I do the same thing on the bottom, I'm going to get 7xy over x minus 6xy over y. Now typically in practice, you're able to actually do this step in your head and cancel. You can see the x's are going to cancel, the y's are going to cancel there, these x's are going to cancel, those y's are going to cancel. And so usually in practice you would just skip this step, you'd distribute the xy over and you'd see the x's cancel, and you just write 6y, which is of course what I have here, and you distribute over here and your y's would cancel and you just get plus 7x. Okay? And then in the denominator, the same thing. Right here, when you distribute this x and this x cancel, so you're left with 7y. Same thing I got here, minus the y's would cancel. I'll get minus 6x. Okay? And notice then that if you can do this step in your head, you get exactly the same answer that we got up here, and it's usually faster and easier. Okay?